Welcome back to the second part of lesson number 5. I've already started the first examples, which is class example number 5. With these questions, we're looking at geometric means. So we're looking at the middle terms in between two bookends, essentially. So in between, in this case, the first term and the sixth term. So I know that the first term is 81, so T1 over A is equal to 81. And I know that T6 is equal to 1 over 729. I also know that T6 is equal to A times R to the power of 5, which is also equal to 1 over 729. So I could also say that since A is equal to 81, that 81 times R to the power of 5 is equal to 1 over 729. Now what I need to do is I need to multiply or divide my 81 out of this side and bring it over here in order to solve for R. And that's what I'm trying to do, is I need to find out what my common ratio is in between each of these terms. And so in order to find those terms, so in order to do that, I need to isolate this R value. So if I have 1 over 729, I need to divide both sides by 81. And so when I do that, I'm going to get R to the power of 5 is equal to 1 over 729 divided by 81 would be times 1 over 81. Let's move up here. So R to the power of 5 then is equal to 1 over 729 times 81. We get 59,049. So R to the power of 5 is equal to 1 over 59,049. Next thing I do is I have to take the fifth root of R to the power of 5. I need to do this on both sides of my equation again. So 1 over 59,049. Now, in order to do that on this calculator, I need to choose this option for fifth roots. Get that out of the light there. So fifth root, go to my math function, choose option 5 here. And let's type in that second answer was 59049. And I get an answer of 9. So that means that my common ratio of R is equal to 1 over 9. Now that I know my common ratio, I can find out what each of these terms are. So that means all I need to do is multiply 81 by 1/9. So 81 times 1/9 is just going to be 9, right? Because if I have 81 and such that what I'm doing is dividing by 9, we get 9. So 81, 9 over 1/9 would be 1. 1 times 1/9 is 1/9. 1/9 times 1/9 is 1/81st. And we already know our sixth term, but 81 times 9 is going to be 729. So those are our 4 geometric means in between 81 and 729. Next, we have a problem that's really similar to what we looked at with arithmetic means. I have 3 terms, so 1, 2, 3, and I'm told it's a geometric sequence, which means we're going to have to find the value of R. Now we need to use the concept of the common ratio in order to determine the value of x and these 2 terms. So I know that my common ratio is equal to T2 over T1, which is equal to T3 over T2. This is the concept that I need to use here. And so let's set our equation up like this. So I know that term 2 is x. I know that term 1 is x plus 3. And I know that term 3 is x minus 5. And x again was what term 2 was. So now that I have this equation written out, I can simplify. So I want to have well, eventually I'm gonna want to make sure that all my variables are on one side of the equation and all my whole numbers are on the other side of the equation. So if I move up here, x times x, if we cross multiply, is x squared, and x plus 3 times x plus 3 times x minus 5. This is an equation you probably remember from last year, but all we're working with is a quadratic equation. If we expand this by using the distributive method, I end up getting x squared minus 5x. If we distribute these x's and everything else, plus 3x minus 15. 3 times 5 is 15. And so when I simplify, what I'm going to get is x squared is equal to x squared minus 2x minus 15. So again, I want to get all my like terms to one side. I'm going to bring my x over here. So I'm going to subtract both sides by x squared, which would leave me with 0 on this side of my equation. I'm going to bring my 2x over here. I need to add it since it's a subtract, or since it's a negative 2x. And I have my negative 15 that I'll leave over here. If I divide both sides by x, I'm going to be left with negative 15 over 2. So I know that that's my value of x. So that means that term 1 is equal to, since it's equal to x plus 3, is equal to negative 15 over 2 plus 3. So negative 15 over 2 plus 3. I need to make both of the, well, remember when you're adding fractions, you need to make sure you have a common denominator. And so my common denominator in this case is going to be 2. So negative 15 over 2 plus. If I want to make this, if I want to give this a 2 on the bottom, I have to multiply both sides by 2, which is going to give me plus 6 over 2, or negative 9 over 2. So that's my term 1. My term 2 is just equal to x, so that means that that's just equal to negative 15 over 2. And term 3 is equal to x minus 5, or negative 15 over 2 minus 5, or negative 15 over 2 minus 10 over 2, which is equal to negative 25 over 2. And I should square that. And those are all my values of x. Now, the last one is another one of those, is another means question. So I have this time though I have the 4th and the 7th term in my sequence. So I have T4, and so if I have T4, then that's the equation itself is a times r to the power of 3, which equals negative 54. And I have term 7, which would be a times r to the power of 6, and that's equal to 1,458. All right, so I'm going to show you 2 ways of solving this problem. Now, first things, like what do we need to even solve for this? So we need to use the system of equations to determine the values of the first term, so my value of a, and the common ratio. And we also need to come up with the general term, or the general formula for this equation, since these are just the general terms or general formulas for T4 and T7. So let's look at method 1 first. So method 1, we're going to start with our value of a being, method 1, T4, AR cubed equals negative 54. Now, we could also substitute a value of a for this equation. So a is equal to negative 54. If I divide both sides by r over cubed, we get negative 54 divided by r cubed. All right, and that gives me a value of a that I can use in my T7 equation, which was term 7 equation. All right, so if I use this and I substitute my value of a into this equation, I'm going to have negative 54 divided by r cubed multiplied by r to the power 6 is equal to 1,458. Now remember that this r over 6 is to the power of 1 and we're multiplying. So if I simplify this, I'm going to be left with negative 54 r to the power 6 divided by r cubed equals 1,458. Now remember, when we are dividing exponents, we are really subtracting them. So I have negative 54 r cubed is equal to 1,458 once I simplify this. And I'm going to have to divide both sides by this negative 54. So negative 1,458 divided by negative 54, I'm going to be left with r cubed equals negative 27. And if I take the cube root of both sides of this equation, r is going to equal negative 3. So that's my common ratio. Now these are just methods for finding the common ratio. Method number 2, you'll probably find is, maybe a little more, maybe a little more logical. Well, not logical. Like both ways work really well. The math is, if you're practicing your algebra, then the math should make sense. But let's look at how to set up the equation for this second method. So a times the common ratio to the power of 6 is equal to 1,458, and a times r to the power of 3 is equal to negative 54. All right, this is exactly like what we did in arithmetic means. However, in arithmetic means we were subtracting. This time we are going to divide both sides, or top and bottom. Alright, so here's the division sign. A divided by A is just 1. R to the power 6 divided by R to the power 3 would give me R to the power of 3. And 1,458 divided by negative 54, I get negative 27. So when we set it up this way, we right away, kind of skip to this step right here. Now what I need to do is take the cube root of both sides, which gives me my value of r. That gives me negative 3. So, we have our common ratio, which is the same on both sides of our equation. Now, the next thing we want to do is find out what term 1 is. Alright, so we found out what our common ratio is. Term 1, we can solve that by plugging it into either parts of our equation, but let's use term 4 to determine what that is. So term 4 was equal to a times r to the power of 3 is equal to negative 54. And a is our unknown, but our common ratio is negative 3 to the power 3 equals negative 54. Negative 3 to the power 3, we're going to get negative 27. So a times negative 27 equals negative 54. And so if I divide both sides, or if I divide this 27 out, my value of a is equal to, well, of course a is equal to 2. So now I have my common ratio r, I have my value of a, 2, and now what we need to determine is our general term for the formula. So we know that if we have a general term, and I'm running out of space here, but my general term I'm going to determine to be Tn is equal to a times r to the n minus 1. And I know that my value of a is 2 and my value of r is negative 3. And so my general term is Tn is equal to 2 times negative 3 times, or to the power of n minus 1.